Hey everybody, how's it going? It's just past the hour, just checking the clock, make sure everything's doing okay. Hopefully you can all see me nicely. Welcome to the fifth DBA Office Hours. This is our fifth one we've done. We've been rolling since the start of the year. Hopefully you've been enjoying this Office Hours and some of the other Office Hours as well. We got a whole stack of questions in that came in advance, and I'm not even sure if we'll cover them. So feel free to put comments and questions in the chat line, but I'm being honest up front. The likelihood is we might not even get to them. We've had so much good stuff, but if we can jump back and forth, that'd be cool as well. I will say it's 8 p.m. in Perth at the moment, so it's a good thing that there's audio and that there's video, because I've just finished a big plate of garlic prawns. So thankfully there's no aroma coming through the Zoom session, but just audio and video hopefully, and that'll keep things working well. If you see me looking at the left, I simply have another session here so I can actually monitor what you guys see, just in case my audio drops out or my video drops out. Hopefully you get a reasonably good experience. So what I'll do is, without further ado, let's show you all what we actually have floating around in terms of things to talk about today. So where's my slideshow? There we go. So this is the stuff that has come in advance, and I'll fly through them just quickly, and we'll talk about each one in detail as we go. So how does Apex get access to the schema objects without obviously doing grants? Normally as a DBA, if someone wants to see something in the schema X, you have to do a grant, but Apex just, you say this workspace sets this schema, it just seems to happen automatically. What goes on behind the scenes? On a related note, how do we run things as a given user if I don't have their credentials? Now that might sound alarming. That might sound like you want to go, oh, how do I log on as a DBA if I'm not a DBA? But I think this is more the other side of things, where a DBA needs to log on actually with a restricted or reduced level of privilege to mimic what a user would have. How do I avoid passwords in command line tools or in files in general? How do I connect to the database without giving away passwords to the rest of the world, your flat files and the like? What is a migrated row versus a chained row? This is an interesting one. I've got a demo for this one. Why do queries on a tiny table consume lots of I/O? And we'll talk about that one. The difference between public and private synonyms, and what grants we need to take care of those things. And the final one is TNS names.ORA name resolution problems. Someone had some questions there about how that all sort of hangs together. Now, there was one other question, which was a question along the lines of, how does Exchange partition work? And what are the implications in terms of global indexes, local indexes, maintenance, online, offline, etc.? That's a massive topic, so I don't think we'll actually cover that today. I'll try to do my best to cover that maybe in another session, maybe a dedicated session, and we'll see how we go. So, I've got a question. How to possibly fix screen sharing? It was cut out on the right. Is that the same for everyone? Is everyone's screen cut on the right to some degree? It's okay?
Okay. No, I see your entire slide. I'm not sure what Dennis means. Oh, now he says it's okay.
That's fine. I'll proceed onwards. And if you have any dramas, sing out in the chat line and we'll see how we go. Okay, before I get started with the questions, a couple of bits and pieces. I call it bits and pieces because it just sounds a lot better than marketing. Okay, so the first one is, this might take a while to come up, this slide. I'm in India through the first couple of weeks of July in the ODevC Yatra tour. We're doing 7 cities in 9 days. So anyone on the call who's from India, please register. These are great events. We normally have fantastic numbers. There's a whole stack of speakers going, some from Oracle, some from ACE directors, others from all over the world. It'll be a really awesome event. It's great fun to go to India. So that's a little bit of a promo for that. The second one is, people have been asking me about this just verbally and on Ask Tom, etc. Yes, 18 software on-premise is coming. It's not far away. The rumor mill tells me it's sort of middle of the year. That's all I get to learn inside the great Oracle machine. So we're probably maybe looking at somewhere around July, August, etc. That's just a guess on my part, but it's not far away. And while that's more just a case of, well, that's just like every other release of software that comes out. It comes out eventually and I can download it. This is the big one. At OddTug, someone took a picture of this slide for me from the ODTug conference at Kscope 18. Along with 18C on-premise is coming an 18C XE, Express Edition, free database. And unlike previous versions of the database, like the Express Edition, where we had limitations on resource capacity, but also strict limitations on functionality, it was like a half cut down version of Standard Edition. 18C XE, yes, it has the same restrictions in terms of how big a machine you can run it on and how much memory and disk you can use. But other than that, it's pretty much got a lot of features that you would expect in Enterprise Edition. In fact, if you're scrolling through that list there, you might be thinking, well, that pretty much looks like everything that you can get in in Enterprise Edition. And you'd be right. The mindset here is that 18C XE will pretty much be a complete Enterprise Edition version of the database, pretty much to as much as we can make it available to you guys. That means you get things like multi-tenant, you get in-memory, you get partitioning, you get graph and spatial, you get text indexes, you get all the stuff that's in Enterprise Edition in this 100% production usable free database. That sounds awesome. I'm super pumped about this. But the cool thing is that it really just changes. Did I put a slide about this? No, I didn't. It changes the whole game in terms of what you can do as a developer or a DBA. The concept now of every single developer in your organization, every single DBA in your organization, having a free database on their own PC, their own machine, without having to have VirtualBox or stuff like that, something they can just crank out in a Docker VM super fast. And think about the opportunities that might be coming up here in terms of, I could have a developer, I can work in isolation, just like I would with all the other tools. Like I can code in isolation, I can build all my database objects now in isolation, check the scripts into source code control, and then merge that in like I would a normal developer kind of paradigm and check it into like a central development database. The concept of, we could all have to share just one database now because of licensing restrictions or server restrictions or capacity, whatever, pretty much had gone out the window once 18C XE comes along. You will be able to do, every single developer has a database at home, at work, one day on their phone maybe. It'll be amazing. So I'm super excited about 18C XE, so keep your eyes open for that. It's just a couple of months, maybe 1, 2, 3 months away. It's coming pretty soon. This next slide is absolutely no benefit to the Office Hours session whatsoever. This is just me bragging that I got a brand new graphics card for my PC, so I'm super pumped, and I'll be getting more YouTube videos from me, whether you like it or not, soon. Let's move on to our first question before I get too much into graphics cards. How does Apex execute objects? So I got a question here, a follow-up question of 18XE. 1 instance per server. I don't know, but I'll find that, and I'll find that out for you. And the other question is from Oren. Can you disable the Enterprise Edition features in SC? I don't know, but I'll note those all down. I'll speak to Gerald, who's the guy that pretty much runs with XE, and I'll get some answers for you, and I'll blog post about them probably in a day or so, as long as I get in touch with Gerald. So question 1, how does Apex access objects if we don't do any explicit grants? The way to explain that is first to take a slight backward step and hopefully explain what most people are already familiar with, but we'll just fly through it. And that is a package called DBMS SQL. Back in the day when I was a young Oracle developer, this was the only way you could do dynamic SQL in the database. This was before the advent of Execute Immediate, which obviously made a lot of this much easier. But DBMS SQL was effectively like an API layer into what I would call the low-level SQL processing mechanisms. You would end up coding something like along these lines. In the same way that the way an SQL is processed under the covers when you run it, what we do is the first thing is we open a cursor to get access to an area of memory in which we can do our processing. And then we would parse our SQL. And that way we would actually check the SQL for its syntactic validity, its semantic validity, check all the privileges, etc. We might bind some variables and define some result columns such that the database knows what the data types of the bind variables are and what those values are. Then we would execute the cursor. And then if it was an SQL statement, a select statement, and we needed to do things like get rows back, we would then fetch rows, return them into variables, and continue on in an iterative process. And when we're all done, we would close the cursor. So that's actually what happens whenever you do any kind of SQL in the database. But DBMS SQL is the means of exposing that to do dynamic SQL in earlier versions of Oracle. Now, why am I talking about that? There is a package very closely related to DBMS SQL called DBMS sys_SQL. And it works almost identically. In fact, all the calls you can see there on screen pretty much have partnering versions in DBMS sys_SQL. The key difference is if we look at the parsing step when it comes to DBMS sys_SQL. As well as a parse API, it also has, I'll take it back a step. Before I talk about DBMS sys_SQL, the parameters that go into a parse command are the cursor I'm trying to parse, the SQL I'm trying to parse to check for it, and some information about what version of parsing I should be using. DBMS sys_SQL is the same API, but it has this routine called parse as user. And therefore it takes a fourth parameter, which is the user ID as which you would be running this SQL as. Now, that sounds like an incredibly sort of lax means of security. I can log on as some user, and yet I can run and parse and execute SQLs as some other user without ever knowing their credentials or their privileges. And you're dead right. This is something that you should never, ever give to anyone. DBMS sys_SQL is owned by Sys. It's not granted willy-nilly to anyone, and it's not even documented. This is something that simply is done for Apex and particular internal Oracle applications to get access to things to parse them as nominated users. In this case, in Apex, the schema is bound to particular workspaces. So even though I've told you about this in order to answer the questions, fairly obvious caveat here, be really careful, right? Just because you've seen this package called DBMS sys_SQL, please don't jump in and say, hey, that's really cool. I'll go grab that to everyone. Okay, so, etc. That's a really bad idea. This is something that's used internally by Apex. And hopefully that answers that question for you, Dennis, in the sense that no, you should not be using this outside the Oracle sphere. I'll hopefully talk about how to fix this for you in the next question. And what do I mean? Grant it to nobody. Right. Rest assured, you know about it now. It's used by Apex. It's used by other things inside the database. But please, don't go around using this. Don't grant it to anyone. It's owned by SysDBA for a reason. Now that obviously leads on to a second question, which is, well, if you're telling me that this really cool utility is out there, but I shouldn't be using it, what should I be using it for? Okay. Let's talk about how we can run things as a particular user. Now, here's the motivation for why I thought this was a cool question to talk about. And that is, it's so common for someone to encounter some sort of obstacle when they're using the Oracle database because of the privileges issue. Now, that sort of sounds like I'm saying that's a bad thing. That's actually a really good thing. Why? The best security model you can have when working with any database, or in fact, any product that involves data, is that of what I call the least privilege model. That is, you get access to nothing unless you absolutely need it, and then it's given to you. The concept of starting out with everyone getting everything, well, that's when you see all these web pages about how various products, databases, etc., all got hacked and users and data got leaked all over the internet. Even back in the day, way back when Oracle 6, Oracle 7, we used to ship the database with some default passwords for the SysDBA accounts such that people could very quickly get up and start it. Even that very quickly becomes revealed as a big security risk because people forget to change them. So there's a big push that all database vendors should be embracing. Some do it better than others. I'd like to think that we do it pretty much better than anyone, and that is the concept of least privilege. You pretty much get access to nothing. The problem is, the obstacle there is when I'm trying to do things, I try to create a procedure, I can't do it. I try to query a particular table, I can't do it when I think I should. I then go speak to the DBA, and he says, it works on my machine, works fine. That's because obviously a DBA has a much greater level of privilege. And that can be a little bit frustrating if you're a non-privileged user, getting those kind of responses back from people who have the privileges telling you that, well, it's your problem, you have to try sort it out. So the way to solve that, the way to adopt the same privileges and become a user that is not your current user is what we call proxy account usage. And this is a really cool tool for DBAs to do things like testing as a lower privileged account, or even just helping out a user by logging on as themselves without ever knowing that user's password. Because it's a bit of an awkward conversation as a DBA to have with someone to say, yeah, I'd love to help you. What's your password? And I'll log on as you. Unfortunately, a lot of users would quite happily divulge that, but generally it's not a good idea. So as a DBA, we don't want to get customers into the habit of doing that. It's fine, little backstory there. I get phone calls from my bank from time to time, and they've called me, and they'll go, oh, we want to offer you a better deal on something. And they'll go, but we have to make sure it's Connor we're speaking to. So please tell us your name and your date of birth and your account number and stuff. And it's funny how even in that secure environment, when I point out to them that, no, that's a really dumb idea for me to tell you if you phoned me, it's not like they're upset about it. They're like blissfully unaware. They're like, oh, well, but we called you. It's the bank. Honest. You know, how could we be nasty? And so they're not doing it out of malice. They're just blissfully ignorant of the risks in terms of divulging information. So this is where proxy account usage is pretty cool. So this is how it works. You know, as I phone up as Scott, so Scott phones me up as a DBA and says, look, I've got some problems. I can't query this table. And I'll go, yeah, well, can I be you for a while? And I'm going to switch sharing screen and actually show you a demo in SQL Plus. Let's see how we go. So hopefully everyone can see that. So this is how it works. Let's set the scene here. I've got Joe DBA, and he hasn't got the world's most secure password, but please, this is for the sake of the demo. So we connect as a DBA, and he's created a table called Scott, and so he's created a table under the Scott schema, and it's called meant to be public, and it's a one-row table, and he's granted. He doesn't want to grant select to public because that might be a security risk. He's obeying the least privilege model here, but he's going to grant select to the connect and the resource roles because he's fairly confident in the knowledge that every single user on this database gets the connect privilege and the resource privilege. Let's say it's a development database. So he's pretty comfortable now that everyone's going to be able to see this table. Now here's a user called demo. Now, when we were creating the user called demo, we made a slight mistake. We didn't give him the connect role. We gave him just create session, the direct sys privilege. So he actually missed out on the connect role, which is a bit of a problem. So now let's connect as demo, and he can connect because he's got the connect session privilege. But what happens when he tries to query this table called meant to be public owned by Scott? He can't get it. And this is where he jumps on the phone to Joe DBA and says, Joe, you said I'd be able to query this table, but I can't. Now that's a problem for Joe DBA because he'll log on as himself and he'll go, look, I can query it. And this is the works on my machine problem. You know, it's fine for Joe. It's not so good for the guy named Demo. So this is how we can do proxy accounting to actually let Joe, the DBA, observe events as if he was the user called Demo. These are the commands, and they're very easy to do. We alter the user called Demo, and we have a thing called grant connect through Joe DBA. And what that means is Joe DBA is now allowed to proxy into the demo schema without ever knowing Demo's password. This is how Joe does it. He does connect, Joe DBA as before, but then we have the square brackets, and this is the user in which he's going to proxy into. And he provides his own password, not that of Demo. He never knows Demo's password. If we look at it, we actually do a show user command. Joe DBA has actually now connected as the user called Demo, even though he never knew Demo's passwords. So this is proxy grant, this grant connect through is a great way of being able to connect as another user without actually knowing the credentials. And now Joe DBA says, yes, I can see what the problem is. When I'm querying it, I can see exactly what you see as a user. So it's not like Joe is sort of having to do any kind of interpretation. He literally is here connected as the user called Demo. The nice thing with proxy authentication or proxy connect through is I haven't showed it in the demo here, is that, stop the share, is that what's going on here is if we turn on auditing, session level auditing, we will actually see in the audit trail that Joe DBA was the sort of the initiator of the connection, but he ended up as demo. We get both pieces of information in our audit trail as well. So that's a really cool thing in terms of even if you're granting these proxy connect throughs, it's not like it'll just look like, hey, demo logged on there and did something to subvert the database. We actually see that it was Joe DBA, he proxied through demo, and we captured both that information in the audit trail. So it's nice and secure as well. So that's pretty cool. Let's go on back to our slideshow. So these are the commands, just to sort of sum up this topic. It's very simple. It's alt-user demo, grant connect through Joe DBA. So demo is the person we're going to ultimately be connected as, and Joe DBA is the guy that we're giving the privilege to do so in, and that's the syntax. So I'm connecting with my Joe DBA username, my Joe DBA password. So I never use demo's password, and the demo goes in the square brackets. That's the person I'm going to be ultimately connecting as. So pretty cool. So we're on a common theme tonight. So let's talk about how to not reveal a password on the command line. This affects certain platforms more than others. This is the kind of scenario that we're, my image might take a while to come up. There we go. This is the kind of scenario that we're trying to guard against. I log on a window and I run SQL plus Scott Tiger at pluggable database number 1. Someone who's also logged onto that machine in another window or another terminal, etc., but they're logged onto the same server, has done a process listing, grepping for SQL plus, and sitting there right there in the command line in the arguments is that username and password, and obviously that's a bit of a drama. Now, this is a slightly artificial demonstration, right? And the reason for that is this is a Linux box. And you actually don't see this on Linux. I just don't have access to some other boxes to show the demo for you. But I've concocted this. I actually did some graphical cut and paste. But this is exactly the behavior you'll see on some Unixes. So it's not all platforms. Generally, it's most Unixes. So IIX, Solaris, etc. You'll see this, not Linux. And on Windows. You'll see it on Windows as well. Now, you might be thinking, where do I see the list of tasks in Windows? Because if I just bring up, say, Task Manager, normally I don't see that information. But if I'm on the command prompt, I do something like task list. So it's task list with the verbose flag, or you're using some of the freeware tools like from the systemterminals.com, etc. You can actually dig into all the various bits and pieces inside each process or each thread running on Windows, and you can actually see those username and password details. So they're things that you want to obviously guard against, especially if people have access to your server for other reasons, and you'd rather not yield out any Oracle information to them. I'm just looking at the chat line. There was a question there about, do I have access to the user view database when using connection proxies? Yes, you do. You are literally connected as them, Dennis. It's like as if you were connected as them and you had their password. So it's not like something it's not like an artificial connection. It's a genuine connection as the proxy user. Oops, let's minimize that. Let's go back. So as I said, not all platforms. Now, what are some of the quick workarounds that we can do to handle this without going into too much complexity? The first one is taking advantage of SQL plus /no-log, and that makes a reasonable amount of sense. That is, as I can see, the stuff in blue there is what's going to appear on the password list, on the process listing, and so as a result, no one's going to be able to see the passwords. The downside, of course, here is I've now got to go and put the username and password into all of my actual scripts. Now, that probably won't work in most environments because most places nowadays, the developers will be writing scripts and they'll be checking them into source code control and passing them on to an administrator. Or they might be passing them on to an automated tool. It doesn't really matter, but they probably won't be hard coding usernames and passwords in them because they won't know what the username and password is in other more secure environments. So while that's a workaround, it's not generally going to be something that's going to work that well, I think, in a genuine application development environment. The second one is using some piping. And this works in Windows as well as Unix. And that is, if you know the password and it's stored in, say, an environment variable or somewhere else, or a secure file, you can echo the password and pipe it through into SQL Plus, just passing in the username. You can actually echo the username and the password just with a normal slash into the whole thing. Doesn't really matter. Interesting, in Windows, when you do it this way, the moment that script finishes, the entire SQL Plus routine will exit, even if you don't have an exit command, whereas it might not in Unix. But either way, you can pipe the password in to most of the Oracle tools. So data pump, export, import, etc. There's a couple that it doesn't, and I can't remember which ones why. I can't remember which ones particularly, but I also don't know why they particularly chose those ones. RMAN might be one, and perhaps SQL Loader. Maybe not SQL Loader, but yeah, there are a couple of tools I remember I tried this on and it didn't work, but the vast majority are going to work okay. Now, having said that, you can do a lot better than that. A better option than having the password stored somewhere secret, because security by obfuscation, security by hiding things, generally is a recipe for disaster because someone's going to find it eventually. A better option is just not to have no passwords at all. And you can do that with what we call a connection wallet. And this is something that's been around for a long time, way back sort of an Oracle 8-9 timeframe, yet very few people use it. And I think it's just like uber cool, very cool. So there's a little bit of setup work that goes on. Now we need to have a thing called a wallet. So the first place that we need to go is go to our SQLnet.aura file, and we have these two settings in there, SQLnet.wallet override equals true. And then we need to nominate actually where the wallet will be. It's going to be a file on my machine, and I can see there the directory is C Oracle Wallet. That's where my wallet is going to be stored. The next thing I need to do is create that wallet, and I create it with what we call the mkstore command, passing in -create -WRL stands for wallet location. Now I'm going to put it in C Oracle Wallet. And one of the cool things is in 12.1 patched and 12.2, somewhat sadly, you run it and you get the syntax of the command is incorrect. Yet that is exactly the syntax from the documentation. Maybe just try run mkstore to see what the parameters are. You get an invalid parameter there as well. And if you try the help command, you get syntax is incorrect as well. That's a bit silly on our part and a bit poor on our part. But it turns out that mkstore requires Oracle Home to be set. So you need to set Oracle Home, and then it runs fine. That's a bummer because that's not meant to be the case. It's actually logged as a bug. But just so in case you're running this and you want to race off and create a connection wallet, it's a bit sad that it doesn't say Oracle Home is not set. You just get this invalid command error. It's a bit of a bummer, but that's where we are. So assuming you've set Oracle Home, this is what it looks like. I'm creating a wallet, and here we have to nominate what we call a wallet password. That's the thing you don't want to lose. That's like having an encryption key. That's the thing that lets you access this wallet to do things like put entries in it for secure connections. So wallet pass dollar isn't related to any kind of database user. Wallet pass dollar is your access to actually edit this wallet. So I've created the wallet. The next thing I'm going to do is put an entry in that wallet. I'll just move my screen here so we can see the whole thing. We're going to put an entry in that wallet for a thing called Secure Scott. Now, what's Secure Scott? We'll come to that very shortly. But here are my credentials. The username is Scott, the password is Tiger, and I'm binding that to an entry in my wallet called Secure Scott. So effectively, it's like a mapping. A thing called Secure Scott is bound to Scott and Tiger. My wallet is stored. When I run this, it's going to ask me for my wallet password because I need the wallet password every time I want to put an entry or manipulate an entry in the wallet, and it'll be stored away. Then in my tnsnames.aura, I need to create an entry for that tag I just created, that thing called Secure Scott. So there's nothing in the tnsnames.aura that says this belongs to a wallet. It's simply a stock standard tnsnames.aura entry, but it says I'm connecting to localhost DB version 12.2 in this case, but it's the name of the TNS entry that's critical here. So I've called it Secure Scott. It must align with that mapping name we used inside the wallet. So bringing it all together, SQLnet.aura tells me where the wallet is. I put some entries in that wallet, and one of those entries was a thing called Scott Tiger bound to a thing called Secure Scott. And then in my tnsnames.aura, I said, also there's a thing called Secure Scott that points to this particular host, this port, in the normal tnsnames.aura way. With those three things in place, now when I want to connect to the database, I simply, as you can see there, do // @secure_Scott. What that does, sorry, what we got here, someone's asking me about Rack Easy Connect. Services can be used as well in the same way that you saw in the TNS names entry. I was doing service name equals. That tnsnames.aura entry is just a not stock standard tnsnames.aura. You can put all the normal stuff you would put in there. It can connect to a VIP. It can connect to, you can have failover on, etc. You can have all the normal tnsnames.aura entries, and it connect obviously to a service, as my example there. All this is doing is mapping that TNS names entry into an entry into the wallet based on their names. But here's the cool thing. I can do // @secure_Scott. It is connected as scott.tiger, and obviously nowhere on the command line is the username or the password. They're locked away, tucked away nice and securely inside that wallet. Now, what this means is probably most people relate their tnsnames.aura entries with a database. I've got one database called ABC. I'll have a tnsnames.aura entry called ABC. You need to get out of that mindset, because what we have here is a tnsnames.aura entry for each particular username and password combination we want to connect to the database. We end up with one wallet entry and one TNS names entry per each secure login. So that was a login for Scott Tiger, and I called it Secure Scott. If I want to have a login to the same database as, say, Connor, password Connor, I would create another entry in the wallet. I'd call it maybe Secure Connor, or secure is not a special word here. I could call it ABC. And then I'd have a TNS names entry mapping to that as well. So I would have lots of different TNS names.aura entries, one for each entry in the wallet, which might equate to different usernames and passwords. But yeah, connection wallets, easy to set up once you've set Oracle Home, obviously, but really easy to set up and fantastic. All your scripts, all your logons as DBAs, etc., can all just be done through that now, and it's all nice and secure and locked away in a wallet. So hopefully that helps. So what we've got now is we've got proxy connect, we've got secure, we've got no passwords in the command lines, and hopefully, therefore, no need to use dbmessys_SQL. Next question. Let me keep an eye on the time here. What time is it? I can't see it on my screen because I'm on start mode. Oh, we're just past the half an hour. Well, we're getting there. Okay, let's talk about chained rows versus migrated rows. Someone asked what the difference between them are, in fact, what they were. Someone's got, does this mean that any person who sees the command line with Secure Scott will be able to log in as Scott? That's from Judith. That is if you have access to the wallet. Now, what does access to the wallet means? The wallet is stored in a secure location. Now, if I have a OS user account as, say, Connor, I will create the wallet as Connor, and by default, much like an SSL key, the only person that's going to be able to access that wallet will be me at the OS level. And yes, you did right. If I create that wallet under a common account that 35 people have access to, then everyone get access to that wallet. But yeah, if I create the wallet, for example, on my PC, obviously you have to have a log on to my PC to do it, but same thing, as a particular Unix or Windows account owner, that's the only person that's going to be able to utilize that wallet. Hopefully that answers the question. And yes, some good input there from Siraj. The data guide broker uses Oracle Wallet for switchover, failover. So wallets are pretty cool. Okay, where was I? Oh, back to the next question. Thanks for that commentary. That's very useful. Chained rows versus migrated rows. Let's talk about what they are and what the difference is, and whether they're a drama. A lot of people say, "Oh, I've got chained rows. What do I do? What do I do?" So most people will have a database out there with an 8K block size. It's the default. Yes, you can have 4, 2K, 16K, even 32K on some platforms, but the vast majority of us, I would contend, all have an 8K block size, and it works just sweet. Now, that poses an interesting question. What if I have a table called My Table, and it's got 6 columns, and each of those columns are, well, varchar 2 4000. Now, I might not put 4,000 characters into every single one of those columns, but let's say I did. Let's say column 1 had a couple of thousand bytes, column 2 had 3,000 bytes, column 3 had 2,500 bytes, etc. Well, sort of simple mathematics tells me that as all those columns get pretty full, I'm not going to be able to fit a row from that table into one block. It's just not going to fit. How are we going to solve it? And this is how we do it. When we look at an 8K block, every block in the database has a little bit reserved. And that's for things like the block directory itself. It has information about the state of the block, the transactions that are interested in the block, what we call the row directory, where the rows are. So there's a bit of overhead that has to go into every block. It's somewhere in the vicinity of like 150 bytes or so. So, an 8K block being 8192 bytes, we can roughly assume there's about 8K floating around there for us to actually use, depending on the kind of block. But we're talking a very simple, just a heap block here. So row number one, column number one goes into the block. And normally we would store an entire row in the block if possible. But if column one's 2,000 bytes, if column one is 2,000 bytes, column two is 3,000 bytes, and column three is 4,000 bytes, well, that's 7 kilobytes already burned up out of my 8K block. If column 4 in row number 1 still is bigger than, say, a couple of thousand bytes, there's no way it's going to fit. We simply can't get it into one block. It's the laws of physics. So the way we do it is we put an entry, some metadata into the block saying, well, row 1 started here, but he continues on. And we'll find another block into which to put the rest of the row. So column 4, column 5, and column 6. And there's our entire row. This is what's called row chaining. A single row, row 1, simply would not fit in a single block. So we had to chain multiple blocks together to actually hold the data. That's row chaining. One row spanning multiple blocks. Key point here is, before we talk about migrated rows, is part of the first few columns are in the first block and the remaining columns are in the second block. And this obviously could continue on further and further. One thing worthy of note is no matter how small the columns are, once you go above 255 columns in a block, I know back in Oracle 8 and below, we could only have 255 columns in a block. And then we changed it, we lifted that restriction to be 1,000 columns. Even though that restriction's been lifted, the actual information that we can store on a block is capped at 255 columns. So if you have 256 columns, we'll actually start storing them in this similar way. We'll chain the 256 column, even if there was space in the first block, into subsequent blocks. And that's how it works. So let's talk about, now it's a chain, let's talk about migrated rows. That's a slightly different concept. So put aside the table you just saw, which had massive columns with massive sizes. Let's talk about a normal column, a normal table, which probably has rows with maybe 10 or 20 columns, and those columns might be numbers and dates. They're generally fairly small. There might be some small information. So the first row easily fits in the block, as does row 2, as does row 3. Most of the time in our databases, most typical, we can fit lots of rows in a single block. There's row number 8 there. It's employee number 8, and his employee name is John. And in this case, we've got 13 rows in this single block. Now, at this point, we don't put any more rows in here, even though there's some space, because you'll be familiar probably with the % free setting. When I say % free 10, what we're really saying is when there is less than 10% of free space left in the block, we'll mark that block full. And we'll move on to the next block for subsequent inserts. Now, the reason we do that is to handle the issue we're about to show, which is, let's take that row number 8 there, employee 8, e-name equals John, and let's run an update statement. I'm going to update the employee table. The guy's phoned up. He said, look, everyone calls me John on the floor, but my real name is Jonathan, and so I'd like to be known by Jonathan, please. So I'm going to do that update. Well, that's a bit of a drama because, as you can see from the graphic, and this actually happens inside a block as well, the rows are stored pretty much end on end. They're flush up against each other. I can't simply overwrite row number 8 where it sits in that block because I simply can't fit it in there. There's only 3 bytes for John, and I need to stuff now, what do we got, Jonathan? Another 5 bytes in there to bring the total to 8. I can't do it. That's where % free comes in. I will utilize some of that % free space to actually relocate that row into the % free space there. The bit of data where the row originally sat now becomes free for other operations. So I consume a little bit of my % free to actually allow these updates for rows which grow. What happens though now if after some time, or when I created the table, I set % free, say to 1 or 0, that the actual block is absolutely jammed full. So even though I maybe started with some percent free, some rows have grown over time and they've used up that space, or I started with percent free 0 and all the rows are now fitted in that block and there's literally no space left. What happens now when I do this update? Well, I got a problem. And obviously we just don't disallow it. That would be not very functional of us as a database vendor. What we do is we do something simple. It's similar to the chaining concept. What we do is we simply go and get that problem row and we put a little forwarding address there. We say, look, we've moved because I couldn't fit you in here and we've moved you to another block. And in this case, I started with a new block, but it could be another block that's simply got some free space in it that already has other rows. But as you can see, we've sort of left a forwarding address. The subtle difference here is, notice that I didn't move just the column. I actually moved the entire row to a new block. This is unlike the chaining concept where columns sort of sit across blocks. In this case, the entire row got relocated to a new block and I left a forwarding address. So that's that one. That last one there is migrated rows, and we've just covered chained rows before. Now, the obvious question is, should you be worried about this? It just goes on. It happens. We do it automatically. You know, it's not like you have to do anything to take advantage or worry about it happening. So is it a concern? And most people are concerned about performance. Well, let's look at the first schematic of a chained rows. I've got column 1, 2, 3 in the first block and column 4, 5, 6 in the second block. The key thing to remember here is when we index rows in an Oracle database, the index points to the block or the row ID, which then therefore points to the block on disk for where that row starts. So an index entry for that particular row there you can see on screen will point to the first block on the left. There is no reference in the index that points to the second block. We have to follow that sort of forwarding address where it says there's more here. So let's talk about whether it's going to be a drama. What if I run a query like this? Select column 2 from my table where the primary key equals some value, so I'm going to do an indexed lookup. There's no drama with that. Column 2 is in the first block. There's no extra work there. I simply go to that first block via the index row ID and voila, column 2's value is there. I'm good to go. There is no issue with that chained row in that particular circumstance. Let's look at this one. Select maximum column 5 from my table. How about that? Is that a drama? Well, that's not going to be a drama either. Why? I'm not doing any index reads. So what the database will do is it knows it's going to scan every single block from the low, what we call the low high water mark to the high water mark, but for the ease of discussion, it's going to scan every single block for that table, looking for column 5 to get the maximum value. Since I'm scanning every single block anyway, there's not going to be a cost here in terms of following that moving address. When Oracle encounters a block and says, oh, there's no column 5 in this block, it knows that it's going to encounter that column 5 somewhere. It might have already seen it or it might soon see it later on, but it's definitely going to encounter it in the full table scan. So that's not really going to be a drama either. How about this last one though? I'm doing a primary key lookup on column 5. The index row ID is going to take me to the first block. I'm going to look along that block and it's going to say, well, there's no column 5 here. Then I hit this, what I, for lack of a better term, my forwarding address, which then says, yep, to get column 5, you now need to move along to the second block. So that's a doubling of cost. But the point I wanted to make here is just because you have chained rows or just because you have migrated rows isn't necessarily a bad thing. If you're doing a lot of index access, then it might be a drama. If you're doing a lot of full table scans, it's probably not going to worry you at all. One of the key stats I'd be looking at is rather than looking at the number of chained or migrated rows you have, look at the statistic called table. I should have put this in the slides. Look at the statistic called table fetched by continued row. That's the stat that gets incremented when you have to sort of follow along this list of pointers to find the information you are after. If that's a huge percentage of the amount of actual accesses you do, then maybe you want to think about reorganizing that table to reorganize the data, maybe to inflate, to move to fix those migrated rows. But please be aware, you obviously can't fix a chained rows issue. The row simply was too big to fit in a block. You don't want to reorganize a table just because the rows are chained, because they'll still be chained. reorganizing the table is really going to be only of use if you're suffering from table fetch continued rows for migrated rows. So hopefully that helps out. Next question. Oh man, the time is going so fast. A small table, but we have lots of query I/O. First, a little bit of revision. Man, this might be all we get time for today. We need longer office hours sessions. So a bit of revision first. When I have to update a table and I set salary equals, add 10% to everyone's salary, and I go, oh, I forgot a where clause. I need to do a rollback. The obvious question is, how does the database do that? And it's pretty simple, and most of us are familiar with the concept that we have to remember the information that was there before we changed it in order to put it back in place. Let's look at a rough schematic of how this would actually occur. When I do an update, the first thing I'm going to ask the database to do is give me a slot in a slot what we call in the undo header block, which simply says I'm going to allow you to actually start recording some undo such that if you need to roll back, you'll be able to. So here's my employee table. Let's assume the first set of rows sits on block 2754, and there's my first 5 rows. So in that block, I'll record what we call the undo block address. This is where I'm going to record the information in order to roll back this transaction should I need to. So the undo header will now link me to an undo block. It'll say, yep, you're about to change row number 1 in block 2754. If I need to undo the change you're about to do, I need to set the salary back to $1,000. So that's what the information that goes inside the undo. Now that that's been recorded, I'm allowed to actually make the change to the block and say, yep, add 10% to Smith, and he changes from 1,000 to 1,100, as you can see in the left. And then we do the same thing for row number 2. The salary would need to go back to 900, and then I can change Jones on the left to be 990. If my undo block gets full of information to actually undo that transaction, I can simply link in additional undo blocks. And that's when we can see our undo table space is growing to record things like, in this case, block 3, salary 1,500, and block 4, and so forth. So you can see there at the final state, I think that's the last one I did. Do I do one more? Yeah. Sorry, I'll go back. So you can see at the final state, I've made the changes on the left to my block, and I've got sort of a trail of how to undo that information, sort of a list of instructions as to what to do if I choose to do a rollback. So when I do a rollback, I simply look at my block 2754. It says start at undo block address 5.2, which is that block down the bottom there, and I roll back the information in reverse order. So start with row number 4, take the salary, set it back to 2,000. Then move along the pointers and undo that information, go back to salary 1,500. And as I'm undoing this information, I'm also undoing the undo, if that makes sense. That undo now becomes freed up for other use. Row number 2 says go back to 900, and I keep on going. And eventually, when I'm all done, I've cleared out my undo, and my block is back to how it was before. So that's a vast simplification of how undo works, but you get the idea. Store a set of instructions as to add or undo a transaction, and apply them if someone asks you to do a rollback. Way back in Oracle 4, someone said, you know, this transaction rollback stuff's pretty cool, but we could probably use this for queries. And that's where the great thing about Oracle, that read consistency, comes in. The ability to actually run a query at a fix at a given point in time. And this is really cool. This is sort of how it works. You can see on the left, I've got session 1 at 9 a.m. He starts a query. And even though at 9:03, session 2 comes along and changes the employee table, it doesn't matter. Session 1 is going to see that data as it was at 9 o'clock. What that means is, though, at say 9:05, when this, let's say the employee table is very big, at 9:05, when session 1 finally stumbles across block 3217, which is the block that was changed by session 2 at the right there, well, he's going to see that version of the block which has been altered at 9:03, and he needs that block as it was at 9 a.m. So if I've got a table block that was changed at 9:03 and I need to get it as it was at 9 o'clock, what do I have to do? I have to undo the transactions that were applied. I have to do a rollback of that particular transaction. And the time equals the SCN when it comes to Oracle. That's the system change number. So let's walk through that query example in sort of block speak now to see what's going on. So block 3217 had the SCN of 456003. And in fact, the only thing to remember here is the last 3 digits of our SCN. That's the rest I left unchanged. Session 2 came along and said, yep, I need to update the employee table. And so what do? We move along the SCN number because we've moved along that block in terms of its time. So that update says, yep, take block 3217, change XYZ to ABC because that's what the update statement says. Give it a new SCN number, 4567234. As a result, that transaction must obviously record undo because I might want to roll back that transaction. So the undo information says block 3217, if I want to undo the SCN from 234 back down to 003, I would change ABC back to XYZ. That's what goes in the undo information. So session 1 comes along and says, look, my query is I've been running for about 5 or 6 minutes now. So I've just encountered block 3217. I need it at SCN 192. Well, I look in the buffer cache or even on disk and I say, well, I've got a problem here because block 3217 is now at SCN 234. Well, that's way too new for me. If I use that data, I'm returning corrupt results. So what I do is I take a copy of that block because someone else might be using that block as it currently stands. And then because I know that if that block was moved along in terms of time, it's SCN moved, there must have been a transaction to do it. I can go look up the undo for the transaction that session 2 did and apply that to that blocky of the cop. Sorry, that copy of the block. That's Freudian, sir. So I can take the undo in the yellow there and say, let's apply that. And I'll take block 3217 back to SCN 003, which means the employee name was XYZ. Now 003 is less than the initial request there of SCN 192 that session 1 needed. So now my block is correctly up to date in terms of I've taken it backwards in time and I can use it for session 1's query. So that's effectively how read consistency works. It's on the fly applying undo from other people's transactions. At which point you're going, well, thanks a lot, but how about my question? Why am I getting lots and lots of I/O on a small table? Well, let's go to a new share and I'll run a little demo. Hopefully everyone can see that. So I'll start with a little small table called D. It's only got one row, sorry, it's only got one column and it's got 10 rows. And I can query them, 1 through 10. Very small table. Now let's run a couple of queries on that table. So the way I'm going to do it is I'm going to open a couple of cursors. So I've got ref cursor R1 and ref cursor R2. Now let's open those cursors. You can see there at the start I've done open R1 for select star from T and open R2 for select star from T. Now at this point in time, I'm going to run a query that shows me how many consistent gets have I run so far in this session. And I've run 650. Now that's actually to do things like drop the table, create the table, etc. So how many consistent gets is it to actually do a select star from T? Well, we can do that by actually going and fetching from ref cursor R1. So, sorry, as I'm currently, yeah, I did that, sorry, I'll scroll back a bit. So I did print of R1, it just scrolled off. I got my 10 rows back and I went from 650 consistent gets to 654 consistent gets. So I did 4 consistent IOs, 4 logical IOs to print out ref cursor 1, which was just select star from T. Ref cursor 2 is select star from T as well. Now I run host SQL plus and I'm running a secret script. And there's no smoke and mirrors here. I'll show you what the script is shortly. But I've run a secret script that does something. My table is still the same size. There's my consistent get, 654 in this particular session. Now I do print ref cursor number 2, which also is just a simple select star from T. Now look at this query. I did 100,652 consistent gets against a 1 block 10 row table. Why? Well, the clue's there in the second line, which is 9,994 of those, 99,994 of those were actually applying of undo records. Now, what was I doing in that secret SQL Plus session? You can see it there at the bottom of the screen. I did 50,000 transactions against the table called T. Because I'd opened up the cursor on R2, the ref cursor R2, before I did those transactions, when I came to fetch from R2, I had to undo 50,000 transactions worth of data in order to produce the result as it was when the cursor was opened. It's that schematic we just saw in SQL Plus. So that's why you can often see huge amounts of I/O against what appears to be small queries or small tables. What's going on is a lot of undo information is being required. So when you start seeing these things where, for example, queries that used to run fast suddenly run slow against the same data and the same plans, what it might be is a lot of DML going on in your application that's causing your applications to have to do a lot of undo work. And that statistic we saw before, data blocks consistent undo records applied, is where you want to be looking for to actually see what we're up to. Now, I don't want to know what we got up to in terms of questions, but it's not good, is it? We didn't get a long way. Okay, so let me jump forward to a slight we get one. No, I don't think we're going to get one more done, are we? Okay, let me jump through to a couple of concluding slides. That's always a bit of a bummer. I hate it when we don't get all our content done, but we'll save it for the next office hours. How's that? We'll do that. So let me share just a little finalizing screen for us all. So one more slide after this one to talk about. So first of all, obviously, thanks for attending. As I do every month, I apologize for not getting through all the questions. I promise I will put these ones top of the list, the ones we didn't cover, top of the list for next month. Or maybe we might even have a bonus office hours. I don't know, we'll see how we go. We'll see if the interest is there. But the reason I couldn't go over time is because you are not allowed to go anywhere. Because in 5 minutes' time, believe it or not, the next office hour starts. How cool is that? We give you guys so much free content. I hope you enjoy it. We love giving it. Thank you very much for your time, as always. Always enjoy your presence here on the office hours. Chris will be waiting. Jump over to the SQL office hours. So you've got DBA content, SQL content. At the end of this 2 hours, man, you guys are going to be experts. Have a great night, everyone, and we'll see you all soon.